So this is today's problem. We're starting with the same drag race that we had last week. In this case, car A has an acceleration of 8 meters per second squared with a 30-meter head start. As you see, I've tried to notate things so everything has two significant digits now. B has an acceleration of 12 meters per second squared, and C has an acceleration of 9 meters per second squared with a half-second head start. Now, last time I asked who won this race. Now we're just going to take it for granted that car B won this race, and instead we're going to be asking what was its velocity when it passed cars A and C. So, if this is your first time seeing the problem, rather than watching me work it out, you try to work it out for yourself, and then when you're done, you can check your answers against mine. So, here's the problem. Okay, in order to answer this question, I'm going to need to know when car B passed A and C so that I can use that time in an equation that will give us the velocity from this acceleration. So when it passed them would mean when they were in the same place at the same time, which means I'll have a simultaneous x and a simultaneous t. Let me show you what I mean. This equation represents the position of car B given the acceleration of car B, and, well, I guess no car has its own time. I suppose I should just let t be t. That's going to be the position of car B. If I'm trying to find out when it passed car A, I'm going to need to know when the position of car A was the same as the position of car B at the same time. The only difference between these two equations, besides the acceleration, is this head start. Now, assuming that these two meet each other, it means the position of car B and car A will be equivalent, and if I substitute these equations, t will also be the same. I can just solve for t. So xb was, so there's xb, now I need xa. Alright, now if I can just substitute in these accelerations, I'll be good. Acceleration of car A is 8. Acceleration of car B is 12. Algebra time. This reduces to 6. That reduces to 4. Subtract 4t squared from both sides. Divide both sides by 2. And square root. Alright, now knowing when car B passed car A, now I can figure out how fast car B was going using that time. I'll get a decimal approximation at the end. Alright, now that we know when car B passed car A, now we need to know how fast car B was going when it passed car A. We'll be using this equation. If we're looking for the velocity, we can multiply the t to both sides and just kind of drop the deltas for simplification. I just need to multiply the acceleration, 12 by the time. So that's going to be 12 meters per second squared times the square root of 15 and to two significant digits. It's 46 meters per second. So how fast was car B going when it passed car A? 46 meters per second. Now, in order to answer this question, we just need to do the same thing except for C. So, take a good look. I'm going to erase everything that is specific to car A. All right, let's do car C now. Still I'm dealing with car B, but instead of car A, I'm going to be doing car C. Ah, forgot one. And this would be the acceleration of car C. Do have to make one adjustment though. This time there really should make it that. That's how I'm going to account for my 5 half-second head start. So 12 halves squared is going to be equal to AC is 9. Oh, of course. Okay, so I still have the location of car B, location of car C, set them equal to each other. Here's the location of car A. Here's the location of car C. Okay. Well, just time to solve for T. Simplify both sides. This should be 6 T squared. This should be 4 halves. Although, I'm sorry, 4.5. Maybe I should just leave it as 9 halves for right now. So I'm going to multiply both sides by 2/9. It'll be, oh boy, 12/9, which reduces to, don't tell me, 4/3. Okay, my way out of this one is I'm going to take the square root of both sides. Okay, very good. So now I can get all the t's on one side. I will subtract a t from both sides. There's probably a better way to do this, but you know, it's my first try. Let's see here. Ugh, that's disgusting. Yuck. Well, if any of you can find a better way to solve for t, I would love to see it. But that's just the first thing that came to my mind. So I'm going to need an estimate of that. Hold on a second. Oh, I see what I did. order of operations. To 3 significant digits because I have another equation yet. 3. Yikes. Okay, so car B passed car C at approximately 3.23 seconds. So let's see how fast it was going at the time. Plugging that in here. The acceleration of car B still 12. The time now 3.23. Two significant digits, it's 39 meters per second. Okay. So I think from this we can tell it must have passed car C first, and it did it at a slower speed. By the time it had passed car A, it had picked up some more speed. Anyway, that is the speed at which car B passed car A as well as car C.